Theorem 6.5 states, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So in the diagram, if ABCD is a parallelogram, then angle A is congruent to angle C, and angle B is congruent to angle D. Problem 2, using properties of parallelograms in a proof. So in this proof, we're given that parallelogram ABCD exists and is a parallelogram. We're asked to prove that angle A is congruent to angle C and that angle B is congruent to angle D. This is a flow proof, and we begin with the given information that ABCD is a parallelogram. And then from that, we derive three separate things. We can derive on the left that angle A and angle B are consecutive angles by the definition of consecutive angles. To the right of that, also that angle B and angle C are consecutive angles, and to the far right that angle C and angle D are consecutive angles, all by the definition of what it means to be consecutive angles. Flowing downward from each of those, we can state that those pairs of angles are supplementary. That's because consecutive angles are supplementary in a parallelogram. All of those things combined can contribute to what it was that we were trying to prove. On the left-hand side, the fact that angle A and angle B are supplementary and that angle B and angle C are supplementary lead us to the statement that angle A is congruent to angle C because they're supplements of the same angle, and as we know, supplements of the same angle are congruent. A similar argument's made on the right-hand side, knowing that B and C are supplementary and that C and D are supplementary leads us to angle B is congruent to angle D because supplements of the same angle are congruent. Your turn. Use the diagram at the right. Given parallelogram ABCD and that segment AK is congruent to segment MK, prove angle BCD is congruent to angle CMD.